Absolute value functions give us a shape of a V or a point. And in answer to question A, I want to go down to the question below it first. And I want to say that the first symbol, the negative symbol here, would make it open, would make the V open down. Otherwise, if there were no negative sign, it will always open upward in a V. The second symbol indicates whether the vertex will go left or right. And that is always the opposite. So if it's -4, it goes to the right. And if it's positive, it goes to the left. And then the up or down, the final one, is up or down. And that is just the way it is. It's either positive up or negative down. Now this question here at the bottom, what will the coordinates of the vertex be? Well, that really is dependent upon this plus and minus thing. I would expect that on the test, either the plus sign or the minus sign will be gone. So this will be a 4 and a 6. But depending on whether it's negative or positive, it could be either one at this point. Now, before we go ahead and answer A, let's go ahead and look at a couple of examples. So let's see if we can write something here to this question. The graph of an absolute value equation is not straight because the direction of the function changes. And again, it does that at the vertex. And the reason for that is that the input value, when taken the absolute value, can never be negative. So it can never produce a range or an output of the continuous direction. It's really kind of a difficult topic to understand. But absolute value equations, on this first one, we notice that there is no negative sign out front. So therefore, this one's going to open upward in a V. Secondly, there's a 1 on the end. There's no plus or minus anything inside, so it's just going to go up to 1 on the y-axis. So I'll start by putting a 1 on the y-axis. Then, since there is a 4 in front of the x, I'm going to turn that into a fraction because it's in slope-intercept form. And I'll write up 4 over 1 from my point, and I'll put a dot. And I'll do it again just so I get 2 dots. And I'll connect those together with a straight line. With the absolute value function, that is also going to reflect on the other side. And I want to talk about that now. The reason that it's not linear is that if I put in a -1 into the x value, 4 times -1 becomes -4. But But the absolute value of negative 4 is 4 plus 1, and that gives me 5. So the reason I actually put a dot there, I do the reflection, that's kind of why we learned to do it, but it evaluates out to a positive. Again, if I have a negative 2, and I put it in for x, 4 times negative 2 is negative 8, but the absolute value of that is 8 plus 1 is going to be 9, and I end up with that point there. I'll connect those with a straight line. And I have my absolute value function graph. Let's look at one more. That an absolute value function isn't linear because it's always positive. This case here, where it opens downward, would make that untrue because it's actually going to go eventually negative completely. So let's keep thinking about that and what we're going to write. So it's going to open downward. Our vertex is going to be to the left 2. So I'm actually going to put a dot there on 2 on the x-axis. And then down 2. That's where our absolute vertex is going to be. I'm going to erase this dot. All right. So it's going to open downward. I'll look in front of the x for the slope of the line in here. And there is nothing there, so that's a 1. And since it's opening downward, I'm going to go down 1 over 1, because I'll make that into a fraction. And I'll put a dot, and down 1 over 1, and down 1 over 1. And likewise, on the other side, I'll go down 1 over 1, down 1 over 1, and down 1 over 1. I'll connect those with straight lines. So let's talk about why an absolute value function is not linear. Well, what happens is, up to the vertex, the function is actually going one way, and that's an arrow, supposedly. And then all of a sudden, it turns and it goes the other way. Why is that? Well, if the vertex is on the y-axis, that means that when the input value changes from negative to positive, our graph changes direction. Now, when it's not on the x-axis, our input value changes at the vertex from going upward to going downward. Why did it change there? It changed there because we have a vertex that's at negative 2 and negative 2. I think the one that really matters, though, is the x, the input vertex. The fact that we had to move our line to the left 2 is what causes it to change there. We moved it off the 2 that are going to make the change to bring it up to 0. are never linear. They always form the shape of a V.